Have you ever looked at a massive, complex operation, like a factory or a software company, and just wondered how on earth this all work without falling apart? Well, it's not magic. It's all about design. Today, we're going to crack open the playbook of the industrial architect. We're talking about the core principles for designing truly high-performance systems.
Right out of the gate, every architect has to make one fundamental choice that shapes everything else. Are you going to be a boutique furniture maker where every piece is a custom, high-fidelity masterpiece? Or are you a global titanium refiner built for one thing and one thing only, unrelenting, massive scale? This decision isn't just about what you're selling, it literally defines your entire operational reality. So that brings us to the first play in the book, choosing your foundational blueprint. This is all about picking the right type of process, because that choice is what's going to set the absolute ceiling on what your system can achieve. And this really breaks down that core trade-off. On one side, you've got batch systems. Think of a local bakery making dozens of different kinds of bread and pastries. You get tons of flexibility for customization, but the downside is you're really sensitive to work in process just piling up. On the other side, continuous systems. These are built for pure scale, a constant, non-stop flow. The initial capital investment is, huge, but the efficiency you get is just on another level. But what if you need a bit of both? Well, that's where the modern solution comes in, hybrid systems. By using things like modular machinery and real-time data, today's architects can actually get the best of both worlds, the adaptability of batch processing combined with the raw throughput of a continuous flow. This is pretty much how you manage a whole range of different products without letting quality slip. All right, so we've picked our blueprint. The next play is all about diagnosis. We have to find the single element that's holding everything back, the real heart of the business. And this brings us to a really powerful idea called the theory of constraints, or TOC for short. The principle is deceptively simple. Any system, no matter how complicated it seems, can only perform as well as its single slowest part. Think about that. It means that any effort you spend improving anything other than that one single constraint is, frankly, a complete waste of your time and your money. This quote just perfectly nails a trap that so many people fall into. We get mesmerized by the big, impressive steel cathedrals, the shiny, expensive, high-tech machines. But all the while, the real bottleneck, the thing actually holding back the entire factory's output, is that boring old heat treatment furnace tucked away in the corner. So how do you actually find that boring furnace? Well, industrial architects basically have a three-pronged approach. First, they map out the value stream to literally see where work is just sitting around waiting. Second, they use a technique called the 5 whys to dig past the symptoms to the root cause. And third, they do something really simple. They walk the floor and look for the physical cues, like giant piles of inventory just sitting there. Let's play out the 5 whys like a little detective story. A machine stops. Okay, first question, why? Because the fuse blew. Okay, why did the fuse blow? Because the motor overheated. And why did that happen? It didn't have any lubrication. So why was there no lubrication? The reservoir was empty. Now here's the crucial last step. Why was the reservoir empty? Turns out the guy who normally fills it was on leave, and nobody was assigned as his backup. And just like that, what looked like a simple mechanical failure is actually revealed to be a human management failure. This all leads to a really fascinating question, right? In all these incredibly complex systems, where is the most common, most overlooked bottleneck usually hiding? Well, the answer, in a kind of shocking number of cases, really comes down to this one number, 50%. Yup, a full 50% of manufacturing businesses have their actual bottleneck in the quality control department. And here's why it's so sneaky. Because QC is often seen as a non-value added cost, nobody wants to invest in its capacity. So it becomes this invisible wall, causing millions of dollars of inventory to just pile up, all while it's being starved of the resources it needs. Okay, so we found the bottleneck. Now what? Well, now we shift from diagnosis to action. It's time to open up the optimization toolkit and apply what are called the 5 focusing steps. The very first rule, and this one is absolutely critical, is called the mandate of subordination. All it means is that the entire organization, every single machine and every department has to march to the beat of the same drum. And that drum is the bottleneck. The slowest point sets the pace for everyone. This leads to some advice that sounds, frankly, completely backwards. Stop working intelligently. What does that even mean? It means running a machine that's not the bottleneck at 100% capacity, just because you can, is a huge management mistake. All you're doing is creating a massive traffic jam of inventory that your bottleneck has no hope of ever processing. You're just clogging the system. So the toolkit includes some really smart strategies. Things like cross-training your workforce so people can jump in where the blockage is, or using strategic buffering, which is just understanding the difference between a necessary wait, like paint needing to dry, and a wasteful delay. And then there's a real pro-level move, the best constraint strategy, where you intentionally make your most expensive piece of equipment the bottleneck, just to make damn sure it is never, ever sitting idle.
And then there's a rule that is, and I'm not kidding, absolutely non-negotiable, the full kit rule. It says you never, ever start a project until every last component, every document is ready to go. The source material for this is blunt. It says if you cheat on this rule, your system will fall into such chaos that you'll die within 6 months. It's that serious. So that brings us to the final, and you could argue the most important chapter in this playbook. You can design the most brilliant, technically perfect system in the world, but it is guaranteed to fail if you forget about the people who have to actually run it. Let's talk about the human factor. The science behind this is called ergonomics, and it's really just about adapting the work to the worker, not forcing the worker to adapt to the work. The whole goal is to prevent injuries, to cut down on fatigue, and just make work easier and more efficient. It's not an afterthought. It has to be a core part of the design. And you see this stuff in action everywhere. In an office, it's an adjustable chair that reduces back strain. In a factory, it's a lift assist device that stops people from throwing out their backs. In every single case, the ergonomic solution has a direct, positive impact on efficiency. And when you look at the results, you see that good ergonomics pays off in so many ways. Obviously, it reduces injuries, which means less downtime. It also boosts productivity because, comfortable people can focus better. It even enhances quality because fewer mistakes are made when people aren't exhausted. And on top of all that, it improves morale. It's a total win-win. Because believe me, ignoring the human factor has a very real and very steep price. You're looking at more injuries, more people calling in sick, higher compensation costs, lower productivity, and a workforce that's just generally unhappy and more likely to quit. And that is the big takeaway here. Ergonomics isn't some fluffy nice to have. It's not just about being comfortable. It is a hard-nosed, strategic investment in the efficiency, the resilience, and the absolute peak performance of your entire system. So now that you've got the architect's playbook in your hands, I'll just leave you with one final thought to chew on. Take a hard look at your own work, your own team, your own projects. What's the hidden, boring furnace that's secretly holding everything back?